Assalamualaikum and welcome to our video presentations. I am Nur Alina Jihar Binti Roslan from the BA 2324A class, and I will be presenting our research paper on analyzing drug-related death by state, categorizing fatalities by drug type using WEKA. The accuracy of the classifications was evaluated using these WEKA tools on a dataset comprising 18 incidents, 6 attribute, and 18 sum of weight. The study focuses on analyzing drug-related death at a state level to classify fatalities based on the type of drug involved, such as opioid, cocaine, and heroin. By identifying this trend and pattern in drug type linked to fatalities, the research aimed to provide insight for policymakers and healthcare professionals to develop target strategy for interventions and preventions against drug misuse. The rise in opioid-involved overdose death and the concerning trend of heroin overdose involving synthetic opioid highlight the needs of tailored intervention strategy. The methodology include comprehensive examinations of drug-related fatalities to understand the impact of different substances on fatal outcome between states, enabling the customizations of intervention strategy to address specific drug-related issues and improve public health outcome at a state level. To conduct this analysis, we source our data from the UCI nationally named dataset and meticulously clean it for accuracy. Through preprocessing and feature selections, we employ classifications, associations, and visualization analysis using 3 categories algorithm in the WEKA Explorer interface. Our study revealed pattern in drug-related fatalities, highlighting difference in drug classes, overdose occurrences, and populations impact by drug abuse. Finding important risks and variables, including a gender, medication types, and mortality rate, turns out to be crucial in determining the results. Based on our finding, we aim to eliminate the scale of drug-related fatalities and suggest preventive and interventions measures to combat the adverse impact of substance misuse. Our study not only provides insight into the trend but also offers actionable recommendations for addressing the risk factors associated with these deaths.
My name is Natasha binti Fazli. So, I will continue with the literature review and related work. In this literature review, the main aim is to delve into the correlation between the different types of drugs and their influence on mortality rates. It is essential to examine how various drug categories contribute to the fatal outcome to get a comprehensive understanding of the factors impacting mortality. The first research is from Emily Persephis. This research delved in the alarming increase in drug overdose in the United States, highlighting the shift toward the prescription in medication, particularly opioids, as a leading cause of fatal overdose. Notably, the study showcased the risk in the non-medical use of the prescription drugs, with 1 million of Americans engaged in such practices. Based on the National Institute on Drug Abuse, the article analyzed drug overdose deaths in the U.S. involving various drugs from 1992 to 2022. In 2022, there were 107,941 overdose deaths, mainly driven by the significant opioids like Fatalities. Opioids-related deaths continue to rise with a decline in the prescription opioids deaths from 2001 to 2022. Next, based on the research that we found by Christopher Amaral-Hassis, the study examined how the psychotropic drug related to adverse outcome, focusing on the sudden death or sudden cardiac death as the key measure. Among 3,140 article review, 24/7 were selected, mostly from North America and Europe. Auto-spy results confirming that were scarce, highlighting the need for the research to validate the finding and better understand the risks linked to the psychotropic drug use. Therefore, this case study explored the data sets from the type of drug that contribute the most of that. The goal of this analysis is to identify the type of drug that leads to the death to help the parties involved take appropriate action so that the case like this can be reduced in the future.
To get the data for the analysis, the author started by extracting data from UCI machine learning and downloaded the data set from Kaggle. In this study, the authors used a data mining method. Data mining is the process of sorting through large data sets to identify patterns and relationships that can help solve business problems through data analysis. Data mining techniques and tools help enterprises to predict future trends and make more informed business decisions. Decision trees are used to classify or predict outcomes based on a predefined set of criteria or judgment. A decision tree is used to ask a series of cascading questions and sort the dataset based on the response provided. A decision tree, which can be represented as a tree-like graphic, provided precise direction and user input when drilling deeper into the data.
For the findings, firstly we take our data from Explore and Run Machine Learning Code, Kaggle. The data consists of 6 attributes and 18 instances. The attribute consists of locations, where the drug user located. We take the most influential data, which is from 3 places. Next, year is years the drug that were recorded. Drug overdose type consists of what drug is the most consumed drug. Gender is the gender of the drug user. Date is the rate is number death in the year, and type of drug, which are the type of drug that were recorded in this data. This is 6 attributes which classify as locations. The color indicates dark blue as Melaka, red as Negeri Sembilan, and light blue as Kuala Lumpur. From the table, we see that the most influential location is in Kuala Lumpur because it's shown more than others in the data. Attribute selection were made using 2 ways, which are info-gain attributes and correlation attributes evaluations. From the results, we can conclude that 3 most influential attributes is attributes 5, death rate, 1 locations, and 3 drug overdose. Death rate is the most influential data to analyze the overall drug overdose data to consider for decision-making process. Also, both data from info and correlation have the same data, which indicates death rate is the really important one.
So now I will continue with the explanation of classification algorithm selection. According to the table here, the active model finding in the categorizing fatalities by drug overdose attrition dataset reveal significant insight. Through the application of the 5 classification technique, which is decision table, GRIP, 1R, PART, and 0R, the data set accuracy was truly evaluated. Before that, let me introduce a bit what is 5 techniques that I just mentioned earlier. Firstly is decision table. Decision table is a class for building and using a simple decision table majority classifier. Based on this table, the correctly classifier instance for decision table is 100% and the level of accuracy is excellent. Secondly is GRIP. GRIP is a positional rule learner, repeated incremental pruning to produce by reduction report, which was proposed by William W. Cohen as an optimized version of RIEP. For this correctly classified instance also recorded for 100% with excellent level of accuracy. Then 1R is class for building and using 1R classifier, in other words, uses the minimum error attribute for prediction, discretizing numeric attribute, and it also records for 100% correctly result with excellent level of accuracy. Next is PART, which means that class for the generating a decision list. Users spread and conquer builds a practical decision tree in each iteration and makes the best leaf into a rule. This also had 100% correctly classified instance with excellent level of accuracy. Lastly is 0R, which means a class for building and using a 0R classifier to predict the mean for numeric class for the mode is for a nominal class. However, this technique was recorded for only 44.44% for correctly classified instance, which show the not good of level of accuracy. Utilizing the tool, the key influential attributes were selected and the performance of each algorithm method in the dataset was assessed using the training data testing mode. Nonetheless, as none of the method algorithm exhibit an accuracy below 20%, they can all be deemed as good. Furthermore, every model in the confusion metric in categorized or ordered as A is a medium, B is maximum, and C is minimum.
Based on the decision tree, the dataset included active samples, a set of variables including location, year, drug overdose, type, gender, death rate, and type of drug. Any missing values for continuous variable should be omitted during the pre-processing step, but there were no missing values in the used dataset. There are three classes for type of death rate, which are medium, maximum, and minimum, have been selected as it is the most influential. The authors used the J48 classification algorithms in order to classify and visualize the decision tree. It shows that the most contributing dimension is the death rate. The death rate highlighted for low levels is 1.0, which represent medium, and the high level is 7.0, which represent minimum. Now, let's move on to the visualization for trend analysis. The figure 1 indicates the drug overdose types and death rate. As shown in the figure above, the horizontal axis, x-axis, illustrates the types of drugs, while the vertical axis, y-axis, illustrates the total of death rate. There are three levels of rate of death, which blue represent medium, red represent maximum, and green referring to minimal level of death rate. As shown in the figure, the rate of death for cocaine is medium and maximum. For opiate, the rate of death including all levels of type of drug, which are medium, maximum, and minimum. Next, the rate of death for heroin is medium and minimum. So it can be concluded that opiate cause the higher death rate compared to heroin and cocaine. The second figure is year and death rate. As illustrated in figure above, it is observed that between year and death rate from the pattern above, for the year 2018, it has been dominated by blue color represent medium and red color represent maximum. For the year 2019, the total death rate of 4.5 to 34.6 shows that all types of drugs, such as medium, maximum, and minimum, cause death. It can be assumed that only for this year, the type of drug is maximum. Next, for the year 2020, it indicates that the data for the type of drug is medium and minimum. It can be concluded that the death rate is high in 2019. Moving to the third figure, which is category and drug overdose types. As shown in the figure above, we can see that the types of drugs taken by each category, such as adult, teenager, and elderly.
Based on the visualization and trend above, the rate of death for all types of drug is medium and minimum. For teenagers, the rate of death for all types of drug is medium, maximum, and minimum. It shows that the death rate for teenagers who take all kinds of drug is high. For elderly, the data shows the rate of death for all types of drug is medium and maximum. The next figure is types of drug and drug overdose type. As illustrated in figure above, it is observed that between types of drug and type of overdose drug, from the pattern above, the rates of overdose drug for all types of drug is blue color, represent medium level. Next, the rate of overdose drug is red color, represent maximum. According to the trend analysis above, the rate of overdose drug is green color, represent minimum level. The last figure is year and drug overdose type. As shown in the figure above, we can see that the death rate caused by drug consumption by year. For the year 2018, the rate of death for cocaine is medium, maximum, and minimum. Based on the visualization above, the rate of death for opiate in 2019 is medium, maximum, and minimum. It indicates that in 2018 and 2019, the death rate is the same. For the year 2020, it shows that the rate of death for heroin is medium and minimum only. So it can be concluded that the death rate is low in 2020 compared to 2018 and 2019.
This research shows a disturbing rise in opiate-related overdose deaths, with males being particularly impacted. The study also emphasized the alarming trend of heroin overdose, which frequently involve synthetic opioids, demonstrating the complexities of the substance abuse environment. The researchers achieved great accuracy in predicting drug overdose types by employing multiple classification algorithm with the G4X algorithm, decision tree visualizations identifying death rate as the most crucial element. The graphical trends highlight the seriousness of the problem, particularly among teenagers, with 2019 ranking as the year with the greatest fatality rates across all drug kinds. It emphasized the critical need for focused public health interventions and policies to combat the rising tide of drug overdose deaths. This research, through evaluation of opioids and their impacts on various demographic groups, reveals that a targeted multidimensional approach is required to alleviate the negative effects of substance abuse and overdose incidents. It can help politicians, healthcare providers, and public health agencies design more effective methods to reduce drug-related deaths and increase general well-being at the state level. This research makes numerous recommendations to alleviate the growing epidemics of drug overdose deaths. These include targeted prevention and initiative, increased surveillance and data collecting, improved treatment access, policy interventions, public health education, interdisciplinary collaboration, research and innovation, and family and caregiver support. The recommendations are based on the notion that a variety of strategies is required to effectively address drug-related death rates. By applying this measure, legislators, healthcare providers, and public health agencies can collaborate to minimize the number of drug-related deaths and enhance overall public health.